Welcome to the lecture number 17, coordinate geometry. In this case, you will find exercise 5.3 and question number 3. Determine whether the following points are collinear or not. We have already solved the sums of deciding whether given points are collinear or not by using distance formulas. Now this time we'll find out the slope of AB and slope of AC. And if slope of AB is equal to slope of BC, we'll say point B is common in AB and BC and therefore they are collinear if their slopes are equal. So let's see here. So I will find out first here slope of AB. I label this as x1, y1, B as x2, y2. And no matter, C as x3, y3, x1, y1, x2, y2 and x3, y3. So slope of AB is equal to y2 minus y1 upon x2 minus x1. x2 minus x1, that is equal to value of y2. What is value of y2? y2 is 1. Minus of value of y1 is minus 1 upon x2 minus x1. x2 is 0 minus value of x1 is minus 1. So that will give us 1 minus into minus is plus. So 1 plus 1 is 2. Y minus into minus is plus, therefore that is equal to 2. So I obtain slope of AB as 2. So I write over here slope of AB as 2. Now let's find out slope of BC. So slope of BC is equal to slope of BC is equal to y3 minus y2. As here y2 minus y1, simply we have to write now y3 minus y2 upon x3 minus x2. y2 minus y1, in that case y3 minus y1. So 3 minus 1, 3 minus 1 upon x3 minus x2, x3 minus x2, that is 1 minus 0. So here also you will find 2 upon 1, that is equal to 2. So slope of BC is equal to 2. Slope of AB is equal to slope of BC and that is equal to 2 each. So I can write it over here that slope of AB is equal to slope of BC, that is equal to 2, and point B is common. Therefore, points A, B, C are collinear. Points A, B, C are collinear. This is first one. Now second one. Same way we do. For the second one, D minus 2 comma minus 3. D minus 2 comma minus 3. Next to that is E 1 comma 0. E 1 comma 0. And we find F 2 comma 1. F comma 1. Labeling same way as we have labeled in the first question, that a first point we label its coordinate as x1, y1, labeling the coordinates of the second one as x2, y2, and labeling the coordinates of the third one as x3, y3. Here also same way you will find these all some sort of same type. So slope of DE, slope of DE, that is equal to y2 minus y1. So y2 minus y1 upon x2 minus x1, x2 minus x1, that is equal to, substituting the values, y2 is 0, be careful here students, 0 minus of y1 is minus 3. Once again I explain, 0 minus of minus 3, x2 minus x1, 1 minus of minus 2. So that will give us minus into minus as plus. So 3 upon, you will find 1 minus 3 minus is plus. So 1 plus 2 is 3. Therefore, slope of DE, slope of DE is equal to 1. Slope of DE is 1. Now let's find out slope of EF. So slope of EF, slope of EF is equal to, slope of is equal to, EF is equal to y3 minus y2. So y3 minus y2 upon x3 minus x2. Very simple, or we can say mechanical way, y3 minus y2 upon x3 minus x2. So y3, what is value of y3 is 1, minus y2 is 0, upon x3, x3 is 2, minus x2 is 1. So that is equal to 1 minus 0 is 1 only, 2 minus 1 is 1. So in this case also you will find slope of EF is also equals to 1. So slope of DE is equal to slope of EF. So naturally you will find in this case also points DEF are collinear points. But you should write in detail. Please do write in the same manner as we have written for the question number 1, that slope of DE, slope of DE is equal to slope of EF, slope of EF, and that is equal to 1. Point, which point is common? E. Point E is common. Point E is common. Therefore, points D, E, F are collinear. Are collinear points. Third one, for the third one, points given are L2, 5, L2, 5. Next to that is N3, 3, N3, 3. Next to that is N5, 1, n 5,1. So simple, so similar. So let the first point has x1, y1. Second point has x2, y2. Third point has x3, y3. Now I am going to find out slope of Ln. So slope of Ln. Slope of Ln, that is equal to y2 minus y1. y2 minus y1 upon x2 minus x1. x2 minus x1, that will give y2 minus y1, that is 3 minus 5. 3 minus 5 upon x2 minus x1, that is 3 minus 2. That is equal to 3 minus 5. Please try to understand. 3 minus 5 is minus 2. 3 minus 2 is 1 only. So we will get it as slope of Ln. Slope of Ln is equal to minus 2. Then slope of Mn. Slope of Mn, that is equal to next coordinate, y coordinate, next coordinate of y3. Y coordinate the next one minus y2. Same way x3 minus x2. Simply substitute the values. y3 is 1 minus 3, x3 is 5 minus x2 is 3. Please note here, you will get over here 1 minus 3 as minus 2. Be careful. And 5 minus 3 is 2. Please see again. 1 minus 3 as minus 2. 5 minus 3 is 2. These two will get cancelled. So slope of Mn is equal to minus 1, while that of slope of Ln is minus 2. Slopes are not equal. Very important. So please see here the next one. I'll write it here as slope of Mn. So slope of Mn. Slope of Mn is equal to minus 1. Slope of Mn is minus 1. Slope of Ln. Slope of Ln. Slope of Ln is equal to minus 2. Since slope of Ln and Mn are not equal, so we'll write the next step. Slope of Ln is not equal to the slope of Mn. Therefore, points L and N, points L and N are non-collinear. What I mentioned over here, that slope of Ln is not equal to the slope of N. Therefore, points are non-collinear. Now, the next one is fourth one. In fourth one, the points given are, for the fourth one, P 2 comma minus 5, P 2 comma minus 5. The next point is Q 1 comma minus 3, Q 1 comma minus 3, and R, and coordinates of R minus 2 comma 3, minus 2 comma 3. All sums are these mechanical sums, the same sums. So labeling first one as x1 y1, second one as x2 y2, and third one as x3 y2. x1 y1, x2 y1, x3 y2. Now slope of PQ, slope of PQ, that is equal to y2 minus y1, y2 minus y1 upon x2 minus x1. That is equal to the value of y2 is minus 3 minus of y1. Dear students, whenever minus sign is there, you have to be careful here. x2 minus x1, that is 1 minus 2. So minus 3 plus 5 upon minus 1. Please note here, minus into minus gives us plus. So 5 minus 3 upon 1 minus 2. So 5 minus 3 is 2 and 2 upon minus 1. So whenever there is negative sign is even for the denominator, we consider it for whole fraction. Therefore, slope of PQ is equal to we got it as minus 2. So after taking slope of PQ, now I will find out slope of QR. Okay, now I am going to find out slope of QR. Slope of QR, that is equal to coordinates of the next point. The next point is R. So y3 minus y2 upon x3 minus x2. y3 minus y2 upon x3 minus x2. Difference between y coordinates upon difference between x coordinates. So y3 is 3 minus of minus 3, because y2 is what? y2 is minus 3. So 3 minus of minus 3. x3, what is x3? Minus 2. Minus 1, because x2 is 1. So slope of QR is equal to, for the fourth one, slope of QR is equal to slope of QR is equal to, I am finding out the slope of QR now. So we will find here three plus 3 is 6. Slope of QR, is equal to 3 minus into minus plus. So 3 plus 3 is 6 upon minus 2 minus 1 is minus 3. So here also minus 2. I explained you earlier also. If minus sign is there in the denominator, even we can consider that for whole fraction. So slope of QR is equal to minus 2. Now for this question number 4, slope of PQ is equal to slope of QR is equal to minus 2, and point Q is common. Point Q is common. Therefore, points P, Q, R are collinear points. What we have to do? We have to mention that point Q is common between PQ and QR, and therefore we got all these 3 points collinear. So here I finished 4th question of your question number 3. Now I am going to do question number 5, sub question number 5. So sub question 5 of question number 3, all are same type of questions. We have to decide whether given points are collinear or not. If point is common and slopes of they are same, then we should label them as collinear. Now 5th of question number 3. So 5th is R1 comma minus 4. R1 comma minus 4. Next point is S, that S is equal to minus 2. S is minus 2 comma 2. S T is minus 3 comma. T is minus 3 comma 4. Same way. I am repeating the same things again. These all are same types of things. So okay. Label these coordinates of R as x2, y1, coordinates of S as x2, y2, and coordinates of T as x3, y1. Now we'll find out slope of Rs, we'll find out slope of ST, and we'll verify if the slopes are same, point will be a common. So say here first, slope of Rs is equal to, slope of Rs is equal to y2 minus y1, y2 minus y1 upon x2 minus x2, y2 minus y1 upon x2 minus x2. What is y2? Y2 is 2 minus of minus 4 upon x2 minus x1, that is minus 2 minus 1, minus 2 minus 1, that will give us 2 plus 4 upon minus 3, 2 plus 4 upon minus 3, 4 plus 2 is of course 6 upon minus 3, therefore slope of Rs is equal to minus 2, 3 2s are 6, 3 2s are 6, minus 2. Likewise, slope of ST, slope of ST, that is equal to, now what is slope of ST? Slope of ST will be the same, that y3 minus y2, very simple, very simple, y3 minus y2 upon x3 minus x2. Substitute the values of y3 and y2. So 4 minus 2, 4 minus 2 upon x3 minus x2 minus 3 minus of minus 2. So that is 4 minus 2 is 2. 4 minus 2 is 2. Minus 3 plus 2. Minus 3 plus 2. So 2 upon minus 1. That is also equals to minus 2. So slope of ST. Slope of ST, that is equal to minus 2. Now in this case what happened? Slope of RS is minus 2, slope of ST is also minus 2. So our answer is same. So slope of RS, is equal to slope of ST, that is equal to minus 2. Slope of RS is equal to slope of ST, that is equal to minus 2, and point ST is common. Point S is common. Therefore, points RST are collinear points. RST are collinear. All sums are of the same type. Only we have to find out their slopes, and then if slopes we get same, then we have to mention, since their slopes are equal, they are collinear, same sums. So next is sixth one of question number 3. Sixth one, question 3. In this you will find they have given us a minus 4, 4. A minus 4, 4. Then next to that, coordinates of k minus 2. K minus 2 comma 5 upon 2. And third one is n, and coordinates of n are 4 comma minus 2. 4 comma minus 2. So label them as x and y, the coordinates of p as x2, y2, and coordinates of n as x3, y3. Same way as that of all these sums. So we'll find here, first of all I'll find out slope of AK, then I'll find out slope of K. So slope of AK. So slope of AK is equal to, slope of AK is equal to y2 minus y1 upon x2 minus x1. So that will give us, that is equal to y2 is 5 upon 2. So 5 upon 2 minus y1 is 4, but I'll write it as 4 upon 1 divided by x2 minus x1 minus 2. Be careful, x2 is minus 2 minus of minus 4. Whenever we get the second point as negative, and before that minus sign we must place the second number into the bracket. So 5 ones are 5, minus 4 2s are 8, cross way multiplication, 2 1s are 2, divided by, what I did here, 5 1s are 5, minus 8 upon 2 1s are 2. Now minus 2 plus 4, minus 2 plus 4, that will give us, please note here, 5 minus 8 is minus 3 upon 2, and you will get minus 2 plus 4 as plus 2. 2 means 2 upon 1, very important. So 5 minus 8 minus 3 upon 2 as it is, minus 2 plus 4, 4 minus 2 is 2 upon 1. Now minus 3 upon 2, that is equal to minus 3 upon 2. I'll take the reciprocal properties. So 2 upon 1 becomes 1 upon 2. 2 upon 1 becomes 1 upon 2. So that will give us slope of AK. Slope of AK is equal to minus 3 upon 4. Clear? So we got the slope of AK. Now I am going to find out the slope of Kn. Let's see here what slope of Kn I get. Slope of Kn, whenever there is a difference between fractions or if fractions there, you have to be very careful while solving the addition or subtraction of fractions. So next to that, slope of AK we got, slope of Kn, slope of Kn, slope of Kn. The next point is n, coordinates of n are y3, x3. So y3 minus y2, y3 minus y2 upon x3 minus x2. So that will give us, that is equal to, what is the value of y3? y3 is minus 2. So minus 2 minus, what is value of y2? y2 is 5 upon, okay, y3 minus y2 upon x3. What is x3? 4 minus of minus 2, 4 minus of minus 2. So naturally we get it over here upon 1. Okay, now let's simplify it. That is equal to 2 into minus 2 will give us minus 4. 2 into minus 2 will give us minus 4, minus 5 ones are 5. Don't forget to write 2 ones are 2. Whole divided by. Okay? So 2 2s are minus 4, minus 5 upon 2. 4 minus into minus is again plus. So that is 4 plus 2. So minus 4 minus 5 is equal to minus 9 upon 2 divided by 4 plus 2 is 6. 6 means 6 upon 1. 6 means 6 upon 1. Now I am going to transfer 6 upon 1 into the numerator. What I get, the next step I get it as, that is equal to minus 9 upon 2 as it is, minus 9 upon 2 as it is, multiplied by 6 upon 1 will become 1 upon 6. 1 upon 6. So 3 2s are 3 3s are. So minus 3 upon 4. This is the slope of Kn. Ak is minus 3 upon 4, as well as slope of Kn is also minus 3 upon 4. So slope of Kn is also equals to minus 3 upon 4. As per our theory, slope of AK is equal to slope of Kn, that is equal to minus 3 upon 4. Slopes are equal and point K is common. Usually, very simply, we'll find AK and K is common. Then points A, comma K and are collinear. So you will find, dear students, we have done lots of practice of this question number 3. Now 6 questions are there. All the time we have to find out the slope of first line by using first 2 points, then slope of the other line by using second and third, if their slopes are equal. In that case only we'll say the points are collinear, and of course one point will be common in both the lines. So here you will find we finished question number 3 of exercise 5.3. Now question number 4 is then. In question number 4, what they have asked us, they have given the vertices of triangle. What they have given us vertices of triangle, and if vertices of triangle are given, on the basis of those vertices, question asked is to find out the slope of all 3 lines. No need of drawing figure at all. No need of drawing figure. So you will find here question number 4. I am writing over here 5.3. Question number 4 is, if A 1 comma minus 1, B 0 comma 4, B 0 comma 4, C minus 5 comma 3, C minus 5 comma 3 are vertices of the triangle. Vertices of the triangle. These 3 are vertices of a triangle, and question asks, find the slope of each side. Find the slope of each side. Okay, so same way, you all are familiar now that slope of A, slope of BC, and we'll, in this case, in addition to that, even we'll find out slope of ACLs. So I'll label A as 1 comma minus 1, B as 0 comma 4, C minus 5 comma 3, labeling A as x and y2, labeling B as x2 y2, while label this C as x3 y3. Now very simple, find out slope of AB, find out slope of BC, find out slope of AC. So slope of AB is equal to slope of AB is equal to, that is equal to y2 minus y1, y2 minus y1 upon x2 minus x1, x2 minus x1. That will give us y2 minus y1 is 4 minus of minus 1 upon x2 minus x1, 0 minus 1. Correct? 0 minus 1. So 4 minus into minus is plus. So 4 plus 1 is 5 upon minus 1. So slope of AB is equal to minus 5. y2 minus y1, 4 minus of minus 1 it will be 5, while that of 0 minus 1 is minus 1. So 5 upon minus 1 is minus 5. So we got slope of AB. Now let's find out slope of BC. Slope of BC. So slope of BC, that is equal to BC. C is the second point. BC, C is the second point. Y3 minus Y2. Y3 minus Y2 upon x3 minus x2. y3 minus y2 upon x3 minus x2. Now 3 minus 4. 3 minus 4 upon x3 minus x2 minus 5 minus 0. So minus 5 minus 2. So that will give us 3 minus 4 is minus 1 and minus 5. Try to understand here. 3 minus 4 is minus 1 is minus 5 minus 0. So minus 5 as it is. So both the signs will change. Plus, therefore, it is 1 upon 5. So I can write over here slope of BC. Slope of BC is equal to 1 upon 5. Slope of BC is 1 upon 5. Now one more line is left. Slope of AB, BC. Now slope of AC. Be careful now. The coordinates of A. Coordinates of A are 1 comma minus 1. 1 comma minus 1. While that of coordinates of C are minus 5 comma 3. The slope of AC, we have to find out slope of all three sides. So slope of AC, coordinates of A, we label them as x1, y1. And we have labeled the coordinates of C as x3, y3. Therefore, slope of AC is equal to slope of AC is equal to y3 minus y1. y3 minus y1 upon x3 minus x1. Slope of AC y3 minus y1 upon x3 minus x1. The value of y3 is 3. 3 minus of minus 1 upon x3. x3 is minus 5. minus x1 times minus 1. 3 minus 1 minus 1 is plus 1 upon minus 5. Minus 5 minus 1 will give us minus 6. Try to understand again. 3 minus of minus 1 is plus 1. So here 3 plus 1 and here minus 5 minus 1 is minus 6. So it is 4 upon minus 6. 4 upon minus 6. 2 2s are 4. 2 3s are 6. Slope of AC. You find slope of AC, that is equal to 2 upon minus 3, or even you can say it as minus 2 upon 3. It is one and the same, is equal to minus 2 upon 3. So this is how you will find that we have got the slope of AB as minus 5, slope of BC as 1 upon 5, slope of AC as minus 2 upon 3. What thing you notice in this question? Very important thing, that slope of AB as well as slope of BC and slope of AC, their slopes are different. So always remember, because lines are intersecting each other. Okay, lines are intersecting each other. And here, not in any case. Moreover to that, if I like to modify this question, as just for sake of interest, you will notice one thing. I have given one extra point to you, that minus 5 into 1 upon 5. Try to understand this. Minus 5 into 1 upon 5. Product of the slopes of AB and BC is equal to minus 1, because 5 and 5 get cancelled, minus 1. And I have given you one very interesting point which is not given in a syllabus, that whenever the product of the slopes is minus 1, the lines are perpendicular. So what conclusion you can draw from here? That AB and BC are perpendicular to each other, and if you join this AC, then what conclusion you will get? Very interesting. That triangle ABC is a right angle triangle, but no need of giving any sort of explanation of that type. Only question is to find out the slope of AB, BC and AC. So we have got it as 5 minus 5 upon 5 and 2 upon minus 3. Thank you. Here I finished my lecture number 17. See you the next time.